Okay, so it turns out this is a bad question. We can't do that with a t interval because your critical value requires that you know the degrees of freedom, and your degrees of freedom, if you remember, is based on your sample size. So we cannot solve for the sample while using the same critical value. We just don't have enough information for that. So we can only answer questions like that when we're doing a z-critical. So disregard that question, and we'll move on to number 10. Okay, so for this one, notice right off the bat we were given a data set. So the data represents the number of house fires that were started by candles in a sample of recent years. So we are talking about a mean number, so it has to be either z or t. So when we decide that, what we have to look for is, do we know the population standard deviation? And we do not. So this is going to be a t interval. Also, that's further supported because we have a really small sample size. So what we're going to do for this one, because we are given data, the first thing I'm going to do is go to my calculator and put this data set into L1. Okay, now when I go to stat test t interval, this time I want to make sure that I select data, and everything is going to be based off of what we have typed in list 1. So the only thing that I have to change for this problem is the confidence level, which it wants us to use 99%. Okay, so I now have a confidence interval of 4785 to 9297.9, so I'm just going to make it 9298, and there's my confidence interval. So the interpretation, we are 99% confident that the true mean number of fires started by candles annually is between 4785 and 9298. So there's our interpretation. So now, again, just kind of a general question. If we were to construct a 90% confidence interval, so that means we are less confident, what would we expect to happen to the margin of error? So we talked about this on the last page. Using 95 as the baseline, and let me just flip this over again. Using 95 as the baseline, if we increase our confidence level, we have to have a wider interval, therefore we have to have a wider margin of error, because remember our point estimate is in the middle, so this length represents your margin of error that you see on both sides. So if we're going from a 99 down to a 90, it is pretty clear to see that our margin of error is drastically smaller. Okay, so now assume that you later find out that the population standard deviation is exactly equal to your sample standard deviation. So what we're going to do is construct a new confidence interval using this new information. So I still have this on my calculator. We ran this as a t interval because we did not know the population standard deviation. So it based it on a sample standard deviation, which was 1610.3. So what it's telling us to do now is to rerun this using this value as a population standard deviation. So now that population standard deviation is known, that changes this to a z interval. So I'm going to use, let's see, I'm going to use my data. So I still have the data in there, but now I'm going to manually put in a population standard deviation, and I'm going to run this confidence interval. So what happened is I now have a confidence interval from 5,473.7 to 8,609. So this is what I got using a z interval. This is what I got using a t interval. So what do we notice happened? If you're thinking of this confidence interval in terms of like a number line, that sometimes helps you visualize a little bit better what you're looking at. So point estimate in the middle. So now what's happened with my t interval, I had my upper and lower ends at 4,700 and 9,200. Now what has happened is those have gone in closer to the mean, and the mean was 7,041. So now from here to here, this is now my z interval. So what happened? Our margin of error decreased. And the reason for that is because when you do a t interval, it's doing the best it can to make estimates based off of the given information. So if the population standard deviation is unknown, you're now using two estimates. You're using your point estimate as your mean, and you're using a standard deviation estimate based on your sample. However, when you do a z interval, you only have one value that is an estimate, and that's your point estimate, which is your mean. Your standard deviation is now being based on the entire population, which makes it a much more accurate value. So you only have one estimated value with z, whereas with t, you have two estimated values. So the less you're estimating, the more accurate you're going to be. Okay, the last page. A sample of 450 students from a wide geographic region found that 55 attended private school. Estimate the true proportion of students who attend private school by constructing and interpreting the 95% confidence interval. So this is a pretty straightforward one. We're doing proportions. So it's going to be one prop z interval. We have an x value of 55 and a total sample size of 450. So I'm going to go to stat test, one prop z interval, put my information in, and make sure I have my confidence level right. So I now have a confidence interval that shows anywhere from 9.2 to 15.2. That's where we believe that the true proportion is going to lie. Okay, and the last one, obesity is defined as a BMI of 3 or more, 3 kilograms per meter squared or more. A 95% confidence interval for the percentage of U.S. adults aged 20 years and over who were obese was found to be 22.4 to 23.5%. What was the sample size of this study? Okay, so this is based on a one prop z interval, just like we did above. So our formula is p hat plus or minus z critical times the square root of p hat times 1 minus p hat divided by n. So again, calculator is very nice. It can give us these confidence intervals very quickly, but when we have to solve for specific values, you still have to know the formula. So the first thing I'm going to do is I'm going to find my p hat value, which is going to be the average or the middle of my confidence interval. So I'm going to average these two values, and I get 22.95. Now, one thing that we have to remember is p hat has to be given as a proportion, so you have to remember to move your decimal and give it as 0.2295. And we did a problem similar to this before as well. Because the formula has the plus or minus, you have two separate answers. So you need to decide whether you're going to use the plus or the minus, and then use the answer that corresponds to that. So obviously for plus, we're going to the bigger end. For minus, we're going to the smaller end. So I think I did plus in the last one, so I'll do minus for this one. So I need to give this as a proportion as well. So 0.224 equals 0.2295, oops, minus, critical value is going to be 1.96, 0.2295, 1 minus 0.2295, and we're trying to solve for n. So lots of nasty decimals to deal with, but should be no big deal. So subtract 0.2295 on both sides. So here's what I've got. Negative 0.0055 equals negative 1.96. And I'm going to go ahead and simplify this a little bit. And remember, guys, we want to try to round as little as possible until we get to the final answer. Okay, I'm going to divide both sides by negative 1.96. Okay, now I have to square both sides. So I've got 7.87 times 10 to the negative 6th equals 0.1768297 over n. I have to multiply both sides by n to cancel that out, which means I then have to divide by my scientific notation. Oops, sorry. So 0.17682975 divided by my answer. So I get 22,456.5, which means I'm going to round that up to the nearest whole number, 22,457.